Jnanam Paramam Dheyam. Knowledge is supreme.
We are now on to tutorial 5 and we will continue with few more problems based on commutator bracket, and it will be interesting to do some more problems based on this. So, in this set we have completed 3 problems. Let us go to the fourth problem. So, in the fourth problem you have to assume that the states ui are eigenstates of Hamiltonian. Hamiltonian is given to you. Hamiltonian operator is p square upon 2m plus Vx. This is our regular way of denoting the Hamiltonian as the kinetic part plus the potential part, with Ei as the energies, and you have to show that the arbitrary linear operator A, which is when you take a commutator of A with the Hamiltonian, and when you take the average, you will obtain it to be 0. So, this relation you will show for an arbitrary operator A, and then using this relation we have to compute what would be the mean momentum of this state ui. So, let us start doing this fourth problem. You are given a Hamiltonian operator as p square upon 2m. P is an operator, H Hamiltonian operator. So, p square upon 2m plus V of x. V is dependent on the position space, and you have to obtain a commutator of an arbitrary operator A and H. Okay. So, any arbitrary operator on H, you have to obtain this. So, let us get started with this. This would be nothing but AH minus HE. Now, you are also given that H is an operator when operated on the eigenstate will give you a energy eigenvalue Ei ui. This is known. Now, let us compute ui commutator of A H ui. This would be ui, this commutator I have written here will be A operator A operator H minus H A ui. Now, when H operates on ui, it will give me a Ei, and when H operates on this bra, it will again give me an Ei. So, you can see here you have a Ei minus Ei term. So, this one will operate on the left and give you Ei, and this one will operate on the right and give you Ei, and an operator A, which is 0. So, we can easily see from here that this quantity is 0, right. The next part what we will do is we have to calculate a quantity ui p on ui, that is what. Okay. Now, this quantity you will obtain from doing some algebra. You have to use the previous result to obtain this result. So, let us assume, let us start, let operator A be some x. Let us try this. Okay. So, what will be x on H? x on h would be x and h, commutator of x and h would be minus h x, agreed. Now, what we will do is we will try to get this operator in terms of, so let me write it here as h, operator h we saw here was p square upon 2m plus v x. So, p square upon 2m plus v of x. Okay. This is what it means. Now, you need not do this step directly, and remember you know the commutator of x and p. Operator x and p is nothing but I h cross, and x in the previous question, in question 2 you have seen what is x on p n, it is I h cross n p raised to n minus 1. So, this relation we have seen, right. So, here you have 1 by 2m I take outside, I have this plus x on p of x, commutator of x and v. Commutator of x and p will give me I h cross 2 p. So, 2 I h cross p cap upon 2 m. And this commutator of x and v, assuming that v is linear, we obtain this is to be 0. So, this is I h cross p cap upon m. Let us continue with this. What we have obtained here, let me rewrite the last step which we obtained I h cross p cap p hat upon m. This is what we obtain. Now, we have already calculated in the previous example u I x h. Let me take this on u I, this commutator between the u I and bracket. This will be I h cross upon m. Being a constant, I can keep this out, u I p hat u I. This is what I obtain by substituting for the commutator x and h, and this left hand side we know. So, let me swap this. So, u I is p u I. So, this is the mean momentum of the state u I will be equal to m upon I h cross times u I x, commutator of x and h. This we know is 0. So, what we obtain in this result is the mean value of the momentum operator is 0. It is very easy to show this. So, with this example, let us go to the fifth problem. Fifth problem is, you consider a particle in one dimension whose Hamiltonian is given by, in the previous example we had the Hamiltonian h is p square upon 2m plus v x. Taking the same Hamiltonian, we have to calculate commutator of h x, commutator of h and x again commuted with x. So, that we have to calculate, and using that we have to show certain results. So, let us get started with that. So, in this operator, Hamiltonian operator is given to you as p square upon 2m plus v of x. This is the same Hamiltonian which we had in the previous example. We have already calculated what is the commutator of H and X and H. That will be nothing but commutator of H and X. So, if I interchange this commutator operators, then the sign would change. Okay. So, I had in the previous example, I had H, commutator of X and H was I H cross P by M. So, now it will become minus I H cross P by M. Alright. Next is this is what we had X comma H, right. In the previous example we had, okay, sorry. So, we need to rewrite this as, this will be plus. So, let me write this H comma X would be nothing but minus I H cross. So, X, commutator of X and H is minus of commutator of H and X. So, this would give me this value, right. Now, what we do is we take the commutator of X and then H and X and then commute it with the operator X again. So, this would be nothing but I H cross upon M. I can take the constant out and P cap X. Again we have commutator of X and P as I H cross. However, commutator of P and X would be minus I H cross. So, this would give you minus H cross square upon M, correct. So, I have got this by using the commutator result from the previous problem, and the commutator result when you commute with the operator X, then what we obtain is minus H cross upon M. Now, you have to go a step further, in which what I will do now is I will take A, what we will evaluate here now is the eigenstate AI or A. I will place this commutator which I evaluated now between these eigengets. So, this we have to evaluate. Okay. So, before evaluating this quantity, let us do some simplification. So, we know here that when the Hamiltonian operator is operated on the eigenket, we get the energy eigenvalue E A and the ket. This is one thing. Another thing is that when I write this commutator, now I am not solving, I am writing in terms of the operators only without simplification. I am not using the commutator relation, because I want to operate these operators on the ket, eigenket. So, let us take this H and X commutator commuted with the position vector or the position operator X will be H X square. When you simplify this commutator bracket, you obtain this is what you obtain. Okay. It is one more step which I have skipped. So, you can simplify this in this manner. Now, what do you have is you will take this operator and sandwich between the eigen states A, this quantity will then be, when I place this entire thing on the eigenket A, what do I obtain is the first term would give me A. I am placing this operator on between the eigen vectors or the eigenkets. Okay. Now, you can see here again that when the operator Hamiltonian operator operated on the eigenket will give me energy eigen value E A. Similarly, this will operate on this bra and will give me E A. So, I will have 2 E A, correct, one contribution coming from this, another contribution coming from the second term will be A. This is the contribution coming from the first two terms. Let me take the second term. Second term has 2 A x h x A. Okay. So, this quantity we have to evaluate. Now, what we do is we so this x operator square can be written as x times x. So, between this x operators, two operators, I can insert a complete set of eigenket such that I have A between x and x. So, I have one x A prime x A. So, this will be the first term which will give me this first expression, and I have a E A also. So, I will write it here E A minus the second term, again I insert a complete set of orthogonal kit such that I will have A. Now, I will insert two of them. So, here I will insert one and second one I will insert at this place. So, what I obtain here is x cap A prime, then I have a prime h hat A prime x A. This is what I have. Let us now simplify the previous step. So, what was the previous step? Let us simplify the previous step. Commutator of h and x commute with the operator x. This on simplification will result in 2 E A. I can write this expression as a square. This is, you can write this entire term as a square. Okay. It is like calculating the norm. A x cap A prime square. This was the first term. Second term is 2 summation A prime E A prime. Again this would give me E A prime, this term. Okay. So, I am writing for this term, and these two terms I write as square. Correct? This is, I will just rewrite it or just simplify it to EA minus EA prime times the square term, correct. Now, what we want is this term, okay, only this term. So, from this what do we get? We know the value of this term, we have calculated the value of this term. What was it? Minus I h cross p cap upon m, that is what we have evaluated. It was minus h cross upon m, because commutator of h and x was minus I h cross p cap upon m, and the commutator of this quantity, commutator and the operator, was minus h cross square upon m, correct. Now, so let me take this to my left. The quantity in the question, that is E prime minus E A times the square term is equal to h cross square upon 2m. That is what was asked to you to show. So, hence shown. Okay. So, these were the set of 5 problems which we have done in tutorial 5, which gave us the idea or exposure to hands on the commutator bracket, the Bryant-Ket notation, and these examples actually looks difficult, but very easy to solve. If you know the relations of the commutator bracket, and if you read the question properly and understand it, and by doing step by step, you can easily evaluate these problems. So, next time we will continue with the next tutorial 6, which will again will have some challenging problems for you. So, keep solving and keep watching the tutorials for if you have difficulties in solving by yourself.